So in this problem here, we've been given the cosine ratio. It's negative, so we know that has to be on this side. It has to be on this side of the circle. Okay, so we know it's negative. But this is also, so if it's negative, we have to consider there's two quadrants that we can possibly put it in. In this question though, the quadrant is given. Okay, so we're given the quadrant here. So we know that it must reside in quadrant 3. Okay, and we can ignore the possibility that it could be in quadrant 2. Although cosine can be in quadrant 2, we're just going to say it's going to be in quadrant 3. So when we solve for this angle then, I can just draw. I'm going to first of all sketch it in. So I have about, this is about 38%. So we're going to say that it looks maybe somewhere around there. Okay, so that's going to be negative 0.385 to 1. That's our ratio. And then that angle that we're going to calculate here, so I do second cos and negative 0.385. Okay, so what I will always state is that the theta 1 is going to be from the calculator. Now this is not mathematical convention. This is what Mr. Lin does. I'm going to, when I say theta 1 is the angle from our calculator. So our calculator gives us 112.64 degrees. Okay, and we're going to do this using our arc cos. Okay, so I just want to get used to using this notation. So I'm going to, my input for my arc cos is going to be the ratio, and the output is the angle. We never put this into cosine. So the angle is 112.64 degrees. So that's my theta 1. The problem is theta 1 is in the wrong quadrant. I'm going to just do this in a different color. 112.64 degrees. Okay. So theta 1 actually is somewhere around here. And it's locating that position. That's 112.64 degrees. Now that's all my calculator is going to give me. That's all the help it's going to give me. I know it's in the wrong quadrant, but I know that the symmetry for cosine is horizontal symmetry, so I'm going to fold it across, and I know it's exactly right there. So to find out the location of that black point, this one right here, I just need to use symmetry. Well, I know that I can go 112.64 this way. I know I can find a reference angle, maybe use a reference angle. But I also know that this, since it's folding along the x-axis here, I know it's symmetrical across that line. So I know that if I go backwards, negative 112.64 degrees, I end up in the position that I want, in the black position. I can use that angle, or I can do 360 minus that. I'm going to use a positive version of that. And I'm going to use 200, so I'll write it down here, 360 minus theta 1. Okay, and that's going to give me the positive version of that angle, which is 247.36 degrees. And that's going to be my angle measured in that direction. Okay, so that is the standard. Both of these are correct. Negative 112 and 247.36. They both measure the same position. That black dot right there. One is a positive version, the other one is a negative version of that. But now, although we've been given cosine, we have to consider two quadrants. Because the quadrant is given, we only give the answer as one answer in one quadrant. So that's our answer right there. Okay, we ignore the fact that theta 1, we ignore theta 1 because it's in the wrong position. And again, positioning is the most important piece when we're talking about standard positioning. So again, this one here, the standard position angle is given as a position, location with x and y coordinates. So I know exactly which quadrant it's in. It's -2, -8. So maybe somewhere around there. So -2, -8. -2, -8 represents the standard position, the coordinate position of that point. Okay, and we want to find the exact values for sine, cos, tan. Now, since we know the position, we only give one answer for this. Okay, we only have to consider one answer because we know the location of that point, and we don't have to worry about, being in quadrant 2 and 3 or 3 and 4. So when I solve for sine, cos, tan, I'm just going to use Pythagoras. I'm going to end up with square root 68. And again, since I have two sides of the right triangle, I'll give my answer in exact values. And cosine theta is equal to -2 over square root 68. Sine theta is equal to -8 over square root 68. And tan theta is going to be the slope. That's positive slope. It's -8 over -2, or slope of +4. Now, solving for the angle, I can use any one of these. I'm just going to use cosine. Okay, so I'm going to use the inverse cosine. Okay, the input is the ratio. The output will be the angle. Okay, so I have to always remember I'm inputting the right type of information into my cos. I never do cosine of the ratio. I do arc cos of the ratio, and that gives me an output of the angle. And my calculator angle, I'm going to call theta 1. So when I give theta 1, I do second cos of -2 divided by square root 68. And I get 104.04 degrees. So that's equal to 104.04 degrees. Okay, so looking at that angle, I have to make sure that I'm in the right quadrant, because remember, there's always two possibilities. There's always a theta 1 and a theta 2 involved when we undo sine, cos, tan. And 104.04 degrees is in the wrong quadrant. It's over here. It's in quadrant 2. It's that position right there. That's 104.04 degrees. That's not the one I want. That means then I must need theta 2. And my calculator is not going to give me theta 2, but however, I can use the symmetry of this circle to give me theta 2. Now, depending on sine, cos, or tan, we have different symmetries. So in this case here, I have folding symmetry again across the x-axis. For sine, it's going to be folding across the y-axis, and for tan, it's going to be rotation on the opposite side of the circle. But here, using that, I'm just going to subtract from 360 degrees. I'm going to subtract theta 1. Okay, and I'm going to get an angle in standard position. The positive version of this is going to be 360 minus theta 1. I'm going to end up with 255.96 degrees. And that is in the right quadrant. So 255.96 degrees is in quadrant 3, and that's the angle that I want. Okay, that is my 255.96 locates the correct position of -2, -8. Okay, so that's my standard position angle that I want. So this, I have to ignore theta 1 because I know the quadrant. I only give one solution for this because the quadrant is known. And I have to decide whether I'm dealing with theta 1 or theta 2. And based on the positioning, we can tell by the quadrants.